Okay, we've got here a nice integral from the Caltech Math Meet 2025, number 40. We have the integral from pi over 6 to pi over 3, sine x plus cos x over square root sine 2x dx. Okay, so these are always a little tricky because I always kind of forget the formula, because there is a relationship between sine 2x, like the double angle formula, to the single angle here. And it's usually through squaring it. The way I like to think about it is, what I would like to happen is for a u substitution to work. So I want this if the whole numerator was just our du. So how I would do it is just kind of do it without knowing what our u is yet. We'll say sine x plus cos x is going to be dx. And so for this to work, you can think about it like integrating this to get back to our u, but it's pretty easy with sine x and cos x, because like the integral of cos x is going to be sine x, and the integral of sine x is going to be minus cos x. So doing it the other way, if you differentiate this, you're going to get back this. Then what you'll notice is we don't have this u value anywhere, so it's not clear exactly how to use this thing. What I can do, like I said, the relationship is through squaring. So what we'll do is we'll just square this out. We're going to get, just multiplying it out, distributing it, we get sine squared x plus cosine squared x minus 2 sine x cos x. But then of course we can clean up this u squared value. First of all, sine x plus cosine squared x is going to just be a 1. And then this, we can use the double angle formula. This is going to be the same thing as sine 2x. Then from here, all I want to do, you notice we've got the sine 2x here and here. I want to get an expression that is going to work with this. All I need really to do is get rid of this 1 here. If you just do 1 minus u squared, we get 1 minus 1, distributing in the minus to this, plus sine 2x. But then the 1's cancel out and give us 0, and so for 1 minus u squared, this is going to be the same thing as sine 2x. So of course, if you want to, you could kind of just memorize these formulas, but it's nice to work it out sometimes. And so we have everything we need for a u sub now, because we know, again, this is going to be our du up here, and we know this is going to be 1 minus u squared. So we'll go ahead and plug in pi over 3 here. It's a little bit complicated, right? Sine at pi over 3 is square root of 3 over 2, minus cosine at pi over 3, that's going to be 1/2. Then at pi over 6, it's basically just going to be the opposite, just going from sine cosine, so it's going to be 1/2 minus square root of 3 over 2. For the rest of it, we're going to have du, and then this is just going to become square root of this thing right here, 1 minus u squared. Well, this integral should be familiar, but one thing I can do before that, notice this is an even function with u squared, and our bounds actually are symmetric around 0, even though it's kind of confusing. If I just write this a different way and pull a minus sign out of it, let's see that. Writing it this way, it should be clear that this is symmetric around 0, because we've got the same value. If you wanted to like put some label on this, a. So we have the same value here, so it's symmetric around x equals 0. And so even integral symmetric around 0, we can use the principle that we can just change this bound to 0 and bring a 2 out front. Go ahead and integrate. This thing is actually going to be arc sine, so we end up with 2 arc sine of u evaluated from 0 to this thing. And let me clean it up a little bit. We can pull it together with the same denominator like this. When you evaluate at 0, that's going to be nothing. Evaluating at square root of 3 minus 1 over 2, that's not a nice value. I actually looked this up on Wolfram Alpha to see if maybe it ended up being, I knew it wasn't going to be a nice value, but I thought maybe it could be, 20 or something. It turns out it's not, so we're just going to plug it in and leave it. So for my final solution on it, we just get 2 arc sine square root of 3 minus 1 over 2, and that's it. Yeah, I don't remember, but I want to say this angle is something like 21.47. I'll have to check it later to see. I could be way off, but that's what I think I remember. We'll see how good my memory is, if that's real. But so then, yeah, if you get that, you get some decimal answer, but it's probably not going to be pretty. Anyway, that's it for today. Thanks everyone for watching. Have a good day.